This is my mechanical full adder. It works with what I call Capstan-Lever logic. Here you see 3 input levers. Each of them can be either 0 or 1. The full adder counts purely mechanically how many of the levers are 1 and displays the result in binary form here. If all levers are in the 0 position, the result is binary 0, 0. If 2 levers are in the 0 position and 1 lever is in the 1 position, the result is binary 0, 1, that is 1. If 1 lever is in the 0 position and 2 levers are in the 1 position, the result is binary 1, 0. That is decimal 2. If all 3 levers are in the 1 position, the result is binary 1, 1. That is decimal 3. In my first video on Capstan-Lever logic, I have shown you a half adder. This half adder consisted exclusively of NAND gates and filled one entire base plate. For a full adder, one needs 2 half adders. So, with the setup of the last video, a full adder would occupy 2 base plates. The cool thing, my new full adder fits on 1 base plate only, apart from the input and output levers. How is this reduction possible? Well, I figured a way to build a combined NAND XOR gate. Here is a demonstration model. You see the standard NAND gate from my first video. But now the levers also have something on top. A string is attached on the top of the left lever, somewhat more apart from the fulcrum. The string passes through a guidance hole on top of the right lever. Then the string goes around this pulley and then to this weight. If the 2 levers are both in the same position, the weight is down. If the 2 levers are in opposite positions, the weight is up. This is an XOR gate. There is a practical issue with this XOR gate. According to our standards, we need a weight of at least 15 grams here. The current weight is much smaller, about 3 grams. Look what happens if we add the weight of 15 grams. The weight acts back on the levers and forces them to be in the same position. We need to amplify the dragging force on our XOR string with a capstan. This is precisely what happens here in my full adder. Here is the combined NAND XOR gate. The XOR string passes around this pulley and goes around this capstan to the weight. I even doubled the weight since this improved keeping the XOR string tight. Here are the schematics. In my next video, I will investigate different types of latches and flip-flops. I hope you will join me again. Thanks for watching.